Hey y'all, let's talk about inequalities and their graphs. So, what inequality represents the verbal expression all real numbers x less than or equal to -7? Well, just all real numbers x less than or equal to, like that, -7. So, the inequality x less than or equal to -7 represents the verbal expression all real numbers x less than or equal to -7. How about this one? 6 less than a number k is greater than 13. Is greater than 13. 6 less than a number k. So 6 less than a number k would be k, take away 6. Now, if you start with k and then you take away 6, now you're at 6 less than k. Is greater than 13. So k minus 6 is greater than 13. So let's see if you can do these. Go ahead and pause and push play when you're ready to check. So all real numbers p greater than or equal to 1.5 is p greater than or equal to 1.5. The sum of t and 7 is less than -3. Well, the sum of t and 7 is t plus 7 is less than -3, less than -3. Alright, so the solution of an inequality is any number that makes the inequality true. The solutions of the inequality x is less than 5 are all real numbers x that are less than 5. You can evaluate an expression to determine whether the value is a solution. Okay, so what we can do is we can take an inequality and we can take a number and see if that number is a solution to that inequality. So, is -3 a solution to this inequality? Well, let's find out. Let's substitute -3 in for x and simplify. 2 times -3 is -6. -6 plus 1 is -5. And -5 is not greater than -3. Because here's 0, -1, -2, -3, -4, -5. Here's -3, here's -5. Greater than means you're to the right. And -5 is not to the right of -3. It's to the left, so it's less than -3. So, if this is not true, then we would say that -3 does not make the original inequality true, so it is not a solution. What about -1? Let's plug a -1 in for x. 2 times -1 is -2. -2 plus 1 is -1. And -1 is greater than -3. -1 would be right about here. And that is to the right, so that is greater than -3. So -1 does make the original inequality true, so -1 is a solution. Is -1 the only solution? No. Any number that makes the original equation true is a solution to the inequality. This is just one of an infinite number of solutions. Basically, you can pick a number that's higher than this because we're going greater than. Pick a number that's higher than -1 and it's pretty much going to be a solution to this. If you pick like 5, 2 times 5 is 10, 10 plus 1 is 11, and that's greater than -3. So there's an infinite number of solutions to this inequality. So consider this question and see if you can do that. So, which of these numbers are solutions to 13 minus 7y is less than or equal to 6? Alright, so let's start with -1. 13 minus 7 times -1 is less than or equal to 6. 13 -7 times -1 is +7. 13 plus 7 is 20. Is 20 less than or equal to 6? No. So that is not a solution. How's about 0? Is 0 a solution? 13 minus 7 times 0, so that's 13 minus 0. 13 minus 0 is 13. Is 13 less than or equal to 6? No. So that means that 0 was not a solution. How about 1? Negative 7 times 1 is negative 7. 13 minus 7 is 6. Is 6 less than or equal to 6? It's not less than 6, but it is equal to 6. So yeah, that's a solution. And what about 3? Negative 7 times 3 is negative 21. 13 minus 21 is going to be a negative number, negative 8. And is negative 8 less than or equal to 6? Totally, it's less than 6. So 3 is a solution. So, reasoning. In problem 2, how is the solution of the related equation 2x plus 1 equals negative 3 related to the solutions of the inequality? Well, let's see. If we were to solve this, subtract 1 from both sides, then we get 2x equals negative 4. Divide both sides by divide both sides by 2. We would get x equals negative 2. So let's see. If instead of an equal sign this whole time it was a greater than sign, then this would mean x would be greater than negative 2. Well, let's see our solutions over here. Negative 3 is less than negative 2, and it was not a solution. Negative 1 is greater than negative 2, and it is a solution. So pretty much any number bigger than negative 2 is going to be a solution to this inequality. Alright, so you can use a graph to indicate all the solutions of an inequality. N is less than 1. Looks like this. All the numbers that are less than 1. And we got an open circle around 1 to show that this is our boundary, but we're leaving it empty inside because we're not counting the actual place where it's 1. Just everything less than that. A is greater than or equal to 0. So here we've got starting at 0, but our dot is filled in. So make sure it's nice and filled in so we know that 0 counts as one of our solutions. It's 0 and everything greater. F is greater than negative 3. Here's negative 3, open circle because negative 3 doesn't count, and everything greater than negative 3. Negative 2 is greater than or equal to x. So that means, negative 2 is greater than or equal to all of our numbers. So that means that all of our numbers are less than or equal to negative 2. So notice that you can flip this backwards and say x is less than or equal to negative 2. And notice that both times the arrow on the less than or greater than sign is pointing at the x, because the x is what's smaller than negative 2. The x is what's smaller than negative 2. And this sign always points at whatever is smaller. So what is the graph of 2 is greater than or equal to a? Well, if I flip it backwards, then I'll have a is less than or equal to 2. Both ways, the arrow is pointing at the a because the a is what's smaller. So I'm going to make a solid circle at 2, and then wherever the numbers are less than, I'm going to draw a line going in that direction. So pause it and see if you can graph these. Okay, so x is greater than negative 4. X greater than negative 4. Here's negative 4, so I'm going to make an open circle, and then greater than is to the right. For the next one, c is less than 0. I'm going to make an open circle at 0, and then less is left. For this last one, 3 is less than or equal to n is the same as if I was to flip that around. What's the arrow pointing at? It's pointing at the 3, so I'm going to point it at the 3 again. It's n greater than or equal to 3. It's got the equal to sign under it, so that means that 3 counts. So we're going to make a solid circle. And then greater than is to the right. And if you notice, if we write the variable on the left and the number on the right, the inequality sign shows you which way your arrow goes. See x is greater than -4. Start at -4 and go that way. For c is less than 0, start at 0 and go that way. For n is greater than or equal to 3, start at 3 and go that way. So, looking at a graph, can you write an inequality? Well, a closed dot means that it can equal -1, and we're going to the right, which is greater than or equal to -1. So x is greater than or equal to -1. On this one, the open circle says we cannot equal 4, but everything less than 4. So that's just going to be x less than 4. So see if you can write inequalities for these graphs. So this graph starts at -3, and we go less than -3 because we're going to the left, less than, but not equal to. So just x less than -3. On this one, we're going to the right, which is greater than, but we have a solid circle here, so that's greater than or equal to 0. X greater than or equal to 0. Paperclip, it's your secret phrase. So, what inequality describes this real-life situation? Starting at $19.99, if we let c equal the cost of a trail ride, then we get c is greater than or equal to 19.99. Starts at 19.99, and cost always goes up from wherever you start a price. So let s equal a legal speed. That means that our s has to be less than or equal to 8. 8 miles an hour is legal, so you can go 8 or less. So see if you can figure this out. So in part B, can the speed be all real numbers less than or equal to 8? Well, let's see. Can you go a negative speed? Can you go negative 300 miles per hour? Well, that means you're going backwards 300 miles an hour, and that's still, you're going to get a ticket. So really, it's probably between -8 and +8. So here is a summary. X is less than 3, looks like this, and the graph is open circle at 3 and everything to the left. Gives you the less than sign. X is greater than -2, x is greater than -2. Start at 2 with an open circle and go to the right for greater than. X is less than or equal to 0, solid circle at 0, less than is to the left. X is greater than or equal to 1, solid circle at 1, and greater than is to the right. And that's the lesson, and I'll talk to you later.